All right, welcome to today's webinar on seamlessly integrating mainframe data to BI platforms. I am Dustin Froyum, one of the co-founders of VirtualZ, and today I have our CTO and co-founder Vince Ray co-presenting with me. Thanks, Vince.
Oh, thank you. Looking forward to it.
So we're going to do just a brief introduction of PropelZ and how it works and what makes it kind of different from either homegrown or other solutions in the market. And then we're actually going to play a demo. I don't think we've done this for a while in a webinar. So we have a demo that shows moving mainframe data from the mainframe into, I think it's a MySQL database, Vince, and then into Tableau. And that's in a very short elapsed time span. And maybe we can talk a little bit about that and what makes PropelZ different. And we'll talk a little bit about PropelZ licensing and pricing, Q&A, and conclusion. So Vince, let's talk a little bit about the architecture of PropelZ, what makes it different from other solutions on the market. And I guess what we're really representing here is how we can get the database to, staging platforms. Some of these do have some presentation capabilities, obviously with them as well. But Vince, you want to kick us off and just kind of talk a little bit about what makes PropelZ different?
Yeah, I think probably one of the most important differences is that PropelZ is a mainframe application. It's self-contained on ZOS. You run it, on your mainframe, and it directly talks to pretty much whatever database target you want, whether that's an on-prem database server or something in the cloud, or even many at once if that's what you're hoping to do. So PropelZ is designed around the idea that the target is database, specifically anything that's accessible using a JDBC driver. So that puts about 100 different types of databases in context of PropelZ. Any of them can be used. The other important thing there is that PropelZ is all driven by, I'm going to call it configuration data. In other words, if I need to go to, I don't know, MySQL or Microsoft SQL Server or Teradata or, whatever it is out there, we don't have to go back and recode anything in PropelZ. It's all just configuration data. Here are the queries I want to issue. Here's the data types I want to use, and so forth. So speaking of data types, probably the hardest part to get your mainframe data into something like a relational database is understanding all of the data formats you could have with mainframe files. You might have a VSAM file, and in the records of those VSAM files, there might be some text fields, and of course those text fields are probably encoded in EBCDIC. That's not too common off of the mainframe. You might have non-text fields too. You might have binary fields, you might have floating point, you might have packed decimal fields. You have any number of different things in each of those records. And once you get away from the mainframe, those data formats aren't particularly common. So what PropelZ does is we embed a sophisticated transformation engine that can use a little bit of metadata, in other words, a description of what your records look like, to understand how to process those records at a field by field level. This is text, this is floating point, this is packed decimal, whatever you happen to have in that file can be understood by PropelZ. And then typically what we do with that is we transform that into a type that the target database might handle. So, a simple integer value, a binary number, a couple of bytes long, that might end up as a true integer in the target database. And of course, what that means is it behaves like it's supposed to behave. It behaves like a number. If you want to do things like, I don't know, sums or math functions on those columns, absolutely you can do that. That's the real value. So you start out with this complicated VSAM record, and what you end up with is rows and columns like in any other database, and you get to control the format of those columns. You can decide if it's a text field, here's what I want to do with it. Maybe you want to store it as, I don't know, UTF-8 or some other format. I mean, you get to decide that. We provide what we think are reasonable defaults out of the box, at least for 5 of the top databases, and I guess I'll mention them while we're here. Uh, uh, Microsoft SQL Server, MySQL, Oracle, Snowflake, and Postgres are right in the box, ready to go. No customization. Go outside of that, uh, certainly we can help you with that, and really most of that job is what I'm describing here. How do I take a numeric value that was in a mainframe VSAM file? What format do I want that to be in the target database? So, and again, we can do that for you. You're welcome to do it yourself. It's it's a pretty simple task if you have custom things in mind there. The other thing, that PropelZ does is it also gives you a framework for doing incremental updates. You might have really large mainframe file, terabytes, and you don't necessarily want to move terabytes of data over to a target every time that data changes one way or another. You might have a couple of transactions come through and a few 1% of that data changes. You don't want to have to go back and redo that whole file. It could take hours on depending what your network looks like. So we also give you a way of doing incremental processing. What that means is we can keep some information about the file you process and then run again at some future point in time. And that could be 10 seconds later, that could be 10 days later. And then we can look at what's happened on the file and only send changed data to the target. So you only change 1% of the records, 1% of the target gets updated. Makes it really practical to have very large files that are being kept in sync without needing change data capture and trying to synchronize across platforms. The way we work is, you control it. We're not slowing anything else down in the environment. You just run PropelZ when you need to guarantee that the files are synchronized. We'll go through the data, find the new or changed records, and make sure they get to the target properly. So, much cleaner implementation for, at least for what most people need to do there. It's also, PropelZ is also designed to be easy to integrate with things, whether that means kind of production workloads. You might have a file that gets created every day by, God knows what batch processing. And maybe what you want to do is right at the end of that process, you want to be able to capture the content of that file, make sure there's a copy, I don't know, let's say in an Oracle database in the cloud somewhere. Well, it's an easy thing to do to add PropelZ as maybe another batch job step or trigger it by your job scheduling product, however you want to run it. It's very easy to do that kind of thing where it's part of the production workload. And now you're, every time that file gets created, you guarantee that the target's updated. You can also use PropelZ in more of an ad hoc way. You might have, it's so easy to use. I'll call him a semi-technical business user, could definitely log on to the mainframe type in a PropelZ command and push some data around, depending on what his needs are. So it's really both. It's really useful in a production environment where you're doing the same thing over and over again. It's also useful in an ad hoc environment where gee, I need to run some reports against this particular file. Let me use PropelZ, get that data into a target that I can use with whatever reporting tools, BI tools, whatever else I'm trying to do with that. And then, one of the questions we always get is around performance and latency and scale. And again, the PropelZ is, very optimized for all of these cases. Number one, as I mentioned, it's self-contained and runs on the mainframe. It's not like some of the other solutions that are out there where, first you take your mainframe data, transfer it to some mid-tier, and then you run another application on the mid-tier that populates the target. In those kind of solutions, you're going to make 2 or 3 passes through that data. And of course, that's going to take a while. In our approach, the single pass through the data, it all happens right on the mainframe. So it's happening at mainframe I/O and network speeds. It's not constrained by some mid-tier there. The other thing is, I mentioned that we use JDBC generally to talk to the targets. So why that's important is JDBC is a protocol, a network protocol that's optimized for big data volumes talking to databases. It's not like some of the competing products that use, just as an example, HTTP transactions, which are generally text-based protocols. They're designed for relatively small amounts of data. And we don't have any of that. We use kind of the industry standard protocol. Here's how you do remote access to a database over a network, and the performance really can scream depending what your configuration looks like. And give you an idea of that. In our test environment, and keep in mind our test mainframe is about the smallest mainframe you can have. We have one single CPU engine, and you'll see this running in the demo that Dusty's going to show. But it's constrained to 3% of that one CPU engine. And of course, we're not using anything beyond, I'm going to call it consumer grade gigabit Ethernet. And the target is a database that happens to be free tier in the AWS cloud. So, it's not an enormous database. And yet, in that configuration, we have, generally no trouble getting 6 to 10,000 rows per second. And those are with big rows. The data we test with, the records tend to be a minimum of about 1,000 bytes each. So it's not like we're doing little teeny 80 byte records. We're doing large chunky records with lots of different data types, lots of different fields, going over relatively slow network and really slow environment, and we still can get respectable performance there. We would think that big site with a real modern mainframe, Z16, whatever it is, that has robust network connections, you should be able to get 10 times the throughput that we do. And then finally, last thing I'll mention that's really important is that everything we do in PropelZ is zip eligible. So what that means is that all of the PropelZ processing will execute on a zip processor where it's not driving up your software bills, not just for our product, but for everything else that runs on your mainframe. So, it's very cost efficient in that way. And again, compared to some of the alternatives that might have you do, I don't know, FTP or, some utility to move the data and then, run other things in other places. I mean, a lot of those parts that you run on your mainframe end up consuming general purpose MIPS, which absolutely do drive up the cost of software there. So, a lot of advantages to it, very flexible, very simple. I mean, just in the time I've been talking, we probably could have taught most people here's how to be productive with PropelZ. Very, very simple that way. And by the way, that extends to the installation process, the configuration process. I mean, it is a very simple tool to get running with, and it adds just a huge amount of value if you need to get that mainframe data, unlocked on your mainframe and pushed to whatever target you need that way. So Dusty, what did I miss? Is there parts I should have covered that
No,
I didn't?
I think that's pretty good. I got a couple questions for you when we get to the QA piece, but I think that's a good setup for the demo. So Vince, in the demo we're about to see, can you just talk a little bit about the full elapsed time? I think the demo is about 8-9 minutes, but the full elapsed time of actually, installing Propel, setting it up to move the data to the MySQL database, and then presenting it in Tableau.
Yeah, and I mean, there's certainly a number of different parts here. I mean, we've seen in working with some customers who've done proof of concepts with PropelZ, they're able to take the distribution and have it installed and running. I mean, literally within 30 minutes or so. A lot really just comes down to your own change control procedures. If you need permissions and 10 people have to sign off on it, that's where you're going to spend the time. The time to actually install PropelZ is really, really trivial that way. And then once you're connected to the target, and again, what you're going to see in the demo, is a VSAM file with about just under 80,000 1K records, and it's information about all the world's airports. Name of the airport, latitudes, longitudes, elevation, URLs. I mean, and we use that data because it kind of meets that criteria I talked about before. It has just about every type of data in it: floating point, binary, integers, all sorts of things. So, ripping through that data to get it to the target, and you can keep in mind this is a trivially small mainframe system running here. Generally that's no more than 2 to 3 minutes in our testing. In fact, just to put some perspective on that, the way we do our QA testing, we actually use that same input file, and we spin up each of the databases that I described, MySQL, Microsoft SQL Server, Oracle, Postgres, Snowflake, we spin them up from nothing, run PropelZ to populate them, and then we run a bunch of queries against it to make sure that the data is intact. We're able to do all 5 of those targets in 10 to 15 minutes generally is what that full test takes. So it is kind of instant gratification that way, and that's an important part of what we do. Now, the demo shows that data going into Tableau, but as you see the demo, I mean, once that data is in the target, it could be anything. It could be the Microsoft Power BI. It could be SAS. It could be fill in the blank, your favorite BI analytics reporting, whatever you need it to be on the target that way. So
Okay.
yeah. So let's see the demo. I'm sure it'll all kind of crystallize when you see it in action.
So I'm gonna experiment here with audio. I'm gonna put my mic on mute, but I want to just hopefully you can hear the audio of the demo while my mic's on mute, and maybe that'll make it work better. So Vince, maybe type me a thumbs up if you can hear it. Otherwise, I'll unmute and restart it. All right, so that was obviously that was one presentation of the data using PropelZ and one database, but really flexible. You can use any presentation that's compatible with your relational database that you're using. So, just a little bit about the pricing and licensing model of PropelZ. It's a very cost-effective solution. It's $50,000 per year per enterprise, so that's really unlimited installs, volumes of data. It's really $50,000 per year. And that includes the 5 drivers that Vince mentioned. If you want us to test and certify an additional driver and package that up, that's a pretty nominal expense, $5,000 to $10,000, and we're happy to do that. So again, not a huge expense, and then we'll incorporate that in your package if you're interested in that service. There's quite a few other use cases for PropelZ around tape data archiving, migration. Also, we have the ability to stream like SMF data and other mainframe observability data into an observability platform, or you can store it to store like DB2 logs or store your SMF data either for retrieval in the future to a low-cost storage solution. So very, very cost effective and cost competitive in the market. So we have a little time for some QA. And Vince, I'm going to start off with one question. So can you just talk a little bit about the architecture a little bit deeper? And I know we've talked a lot about vSAM and file data, but can we get to other types of data as well on the mainframe side using PropelZ?
Yeah, no, that's a great question. And yeah, the way to think of it is PropelZ is really 3 independent parts. There's an input stage, which is where does the data come from? And throughout the discussion here, we've been mostly talking about the defaults, reading files on the mainframe. But really, it can be any type of data. We've had customers talk to us about, how might I get data from an IMS database to the cloud? Well, an easy way to do that would be to run an IMS utility that queries data out of an IMS DB environment and then just pipes that into PropelZ. It's just a memory pipe, so it's very fast, and whatever travels across the pipe is fine from a PropelZ point of view. And Dusty, you mentioned that we can work with things like SMF data or console messages. That's exactly how that works. We can give you a SMF data listener that captures SMF records in real time and then pipes them to PropelZ exactly as I'm describing here. So, completely open-ended in that regard, and you can plug in any source that you want. The middle stage, the processing, is really where the data transformation and understanding the structure of the records, and that's the important heavy lifting that goes on there. And then the final stage, the output stage, is really is again, just like the input stage. It's here we're talked throughout the presentation that it's JDBC to get to a database either on-prem or in the cloud. But again, that could be anything that you want it to be. It can be you can replace our JDBC output stage with for instance, something that does HTTP transactions or Kafka events, or whatever you need to do with that data. Now, in that case, typically you don't want to transform the data into rows and columns. Typically, you're going to transform the data into something like JSON or XML. or even CSV formats. We support all of that. So, if I wanted to, let's say read a file, transform that file into, a JSON object, and then pipe that JSON object into something that's going to do a web service call to push that data into an API from a product like Splunk or into some custom application that you might have. Absolutely, you can do all of that with, just the version of PropelZ that comes in the box today. Again, the most common case is what we've been talking about. It's files input and databases output, but it is open in that regard, and we're be more than happy to show you how to bend PropelZ to work with whatever inputs and outputs you wanted to have.
So Vince, I don't think there's a specific question on this, but just can you talk a little bit more? I know this is a little off topic from the BI presentation, but it's still important. A little bit about how the SMF piece works. And I know we can stream that real time. We can archive that. And it's not just SMF data, right? It can be console messages, DB2 logs, etc. Can you just dive into that a little bit further?
Yeah, so in the case of SMF, one of the things that we can provide is just a standalone utility that's able to connect to SMF in real time. And by the way, I want to be really clear about that. What we want to do is capture records as they're written in memory. We are not talking about go read a bunch of SMF data sets after they're written. This is live in real time. So, and the reason that's important is you might want to use that SMF data for, say intrusion detection or, something like that, where you don't want to see it 20 minutes after it's been written. You want to see it right as that record occurs. So, you can use our SMF listener to register with SMF, and there are various options there. Do you want to see all of the records or filter them, to certain types? Many different options to tailor what you're going to get as input. And then those records are piped into PropelZ, and PropelZ does its usual thing. It's going to, typically push those records to, a JDBC data source, which, means you'll be able to get, let's say an Oracle database with copies of all records that we've captured. You could use that for things like just archiving. Many customers tell us they keep their SMF data for decades, and so suddenly storing that in a cost-efficient way gets to be a big problem. PropelZ can kind of open up a lot of new sources for that, and using a database is an interesting option here because those tables can have things like timestamps and some other descriptive information in them. So if I need to run a report that's give me last October's SMF data, that's just a simple database query to get to that. So again, a lot of flexibility in how we record that, where you put them, and again, if you really are needing that data for archival purposes, you might have maybe even multiple copies, copy in Oracle, copy on-prem in a whatever type of database server. I mean, it's really sky's the limit that way, based on what you do. And of course, I probably should have mentioned this earlier, but a lot of folks are concerned about the sensitive content in SMF, and again, as long as your database supports encrypted connections, and these days I think all of them do, that can be as secure as you want it to be. So yeah, a lot of good alternatives there. No code needs to be written to do what I'm describing. You're free to retain that data any way you want to. And, Dusty, as you said, it's not just for the data. You might take your console messages and instead of, just archiving them someplace, maybe you want to send those ZOS system console messages to uh, whatever you're using for log aggregation. I mean, Amazon has one of those, Google has one of those, Microsoft has one of those. You have products like Splunk or Logarithm. I mean, there are many different solutions for that kind of stuff. But typically, the mainframe products don't get to play in that. With PropelZ and the listener we have for system console traffic, you absolutely can have all of that data uh, you know migrated into whatever your favorite solution is for consolidated logs. So again, very low cost. I mean, there are probably other ways of doing that, but many of them require big expensive infrastructure and agents on the mainframe and all sorts of other things. Yeah, in our case, we just do it as a function of propels. So easy to get started with, and easy to get value out of.
Hi,
So that's
it's
okay.
Cassandra.
Yeah, go ahead.
Dustin
Go
said I
ahead.
couldn't interrupt. Yeah, this is all great information. And I was I had noticed PropelZ in some publication, and then one of my coworkers we were talking about, and all this is great, and I love the visualization piece. And yes, we have some stuff right now going into Snowflake, etc. So my question is, and I work for Insono, and we're a service provider, right? So we have many, many, many mainframe clients, right? So sometimes we're trying to get there, but we don't always have the opportunity to do real time, right? To put a listener on and transfer the data. So a lot of our current processes, good, bad, or indifferent, is in arrears, right? So we'll get the previous day's SMF data that we process through. And back in the day, if anyone has started in the mainframe or been in the mainframe space for a while, MXG and SAS was like the bread and butter for turning SMF data into usable language, where it takes all that packed data and turns it into a job name that you can just reference the job name and not have to know how to read through a type 30_5 to get all that information, right? So hence, MXG SAS have been around a long time in the mainframe space. So as we keep evolving and growing, it's becoming just a huge process to do it that way. So we're always looking at different ways that someone else already does the breakdown of the SMF records into usable fields that then we can go and do some of the other things we do with that data. Some is visualization, some is creating an SLA metric, some is, various reasons that we look at data after the fact. It's not all, real time is always great, and we are always looking at that option too, to detect anomalies and stuff. But just curious if it has the ability to read a post, not real-time SMF, like a daily SMF file, and could it translate that into a database or into fields that then we just pick those fields and can, do some analysis on?
Yeah. So the answer to your question is yes. If you don't want to use our real-time listener and instead you have, let's say a data set that you created with the SMF dump program, and you want to pass that into PropelZ, you absolutely can do that. What we find is usually that the biggest challenge there is just keeping track of the data sets. As I'm sure you guys are aware, you might have a set of those in every in every LPAR, and so there could be many hundreds, maybe even thousands of data sets.
Correct.
But if you have a way of doing that, and a lot of sites have automated this over the years, or bought vendor products to help them manage that stuff. If you've got that, then yeah, absolutely, you can feed that data into PropelZ and work like that. You could technically do both at the same time as well. You might have some systems, or even maybe you just do things like take one certain record type. Maybe you take, I don't know, the security records, the type 80s out of real time, and a lot of the other stuff comes in more of a batch feed as you're describing. So Yeah, I mean, we should absolutely have a deeper dive on that if, so
Yeah.
we could understand the requirements and, we can give you a better sense of what we can do and, honestly, what we can't do.
Right. Yeah, I
So,
would love to have like a fox. I don't know if you're familiar, if you've ever met Mike Fontanetta, if you've heard the name.
Yeah,
Yep.
we know Mike well.
All right, there you go. So I think him and I were talking about, so maybe it would be worth an offshoot conversation to say and I'm sure he's explained to you kind of how the environment that we currently have in place works. And, we don't have listeners into all of our clients' machines. We typically bring the data over and then we kind of operate in a protected, in no LPAR environment, right? So not that it can't be done. Mike's always about deploying stuff on client site and having it feed, useful data, but we're not there yet across the board. So it'd be nice to see how can we capitalize it now as we keep charging towards that. Because the eventual goal is to not have to process everything through MXG and SAS. It's just a resource hog. It takes up a lot of cycles. And the value is that it decodes the SMF records for you, which is very valuable. Anyone that obviously you guys are familiar with SMF records. So it's nice to have the decoder without having to code the decoding yourself, right? So yeah, that'd be great.
I'll set something up with you and Mike Cassandra.
Perfect.
Thank you.
I appreciate that. No, this is very informational. Appreciate it.
Great. So I wanted to ask one other just quick security question before we wrap up. So I know like masking or exclusion of data comes up, especially in the BI context, right? Where you have very sensitive mainframe data, like a social security number that you don't need in your BI reporting, or you don't want to expose that. Is that something we can deal with in PropelZ?
yeah, PropelZ does, I'm going to call it 2 dimensions of filtering the way you're describing. One is based on, record types or, some content in the record that you can use to wholesale suppress that record. So, let's say you have a big VSAM file and there are many different types of records in that file. Maybe there's names and addresses, that might be one part, but then maybe there's also, I don't know, transactional information with all kinds of God knows what kind of sensitive information. So you might run PropelZ in a way where you say, you know what, I want the names and addresses, but I just want those record types. And that's, I don't know, a 1 in column 703 or, whatever the details are. You can filter in that dimension. That's one part of it. The filtering by different SMF record types is another example of that. You might not want all of your SMF data. You might want only 1 or 2 or a handful of record types. So that's one dimension. Within a record, you also sometimes get, there are some fields you want pushed to the target, other fields you don't want pushed to the target. The way that we handle that is the metadata that describes the record doesn't have to have all of the fields exposed. So in other words, let's say I have name, address, and social security number, and I don't want social security number. I just declare that field as, basically filler, don't process this field. And then the output database will just have name and address. You're able to suppress on a field by field basis that way too. So you can use both of these things in parallel, so a subset of the total number of records as well as only some of the fields within the record. So yes, it is possible to do all of the above. And that is, does give you all of that flexibility. The other thing I'll point out is that the options that I'm describing are kind of run by run of PropelZ. So, if I have, say an ad hoc business user accessing the data, he could see a different view of that data than, let's say, a production job that captures that data and pushes a copy to a database out in the cloud so some other applications can process against it. One might capture all of the data and all of the fields The other can be, just a protected subset. So it's, use by use, you're able to control the things that I'm talking about. And it can all go on, really at the same time if you want. So I can take that, kind of different levels of that data to different targets and, just see what I want people to see for that data. And it's not, in some of our competing products out there, we see, they kind of tie the definition to the data set. So it's, everybody gets the same view. In our case, no, you don't have to get the same view. You get the view that makes sense for what you're trying to do, whether that's security reasons or structural reasons or, whatever it happens to be. So yeah, very very powerful that way.
Thanks, Vince, for answering that one. So just to wrap up, I'll just point out there's some deeper dives into the PropelZ use cases that we talked about, as well as a lot of other resources. So you can go check out additional webinars that go into some of those topics, like tape migration, archiving, SMF data. We've got blogs, solutions, thought leadership papers as well. So there's a lot of resources out on our website, including all the replays, either on our YouTube channel or they're accessible, and demos of PropelZ that we watched today, plus other products. All right, thank you so much for joining us today, and hopefully you'll join us for a future webinar. Thank you.